Hi, and welcome to our Toon shading tutorial. Before we dive into it, we will firstly explain about the state of the art of Toon shading.
We've been looking on the internet for different games that had really cool Toon shaders, and we come across two games, one called Cell Damage and the other one called The Wolf Among Us. Cell Damage is a really nice experience when you're playing it. The characters, their vehicles, their active landscape, everything is really nicely drawn and animated. When you're playing this game, you can almost feel like you're playing a real-time cartoon. The Wolf Among Us is at the top because this game has its own engine. The guys who created this game have their own engines for games like this. If you look 2 years back and see Walking Dead and compare it to this game right now, you can see how much it is increased. So I think The Wolf Among Us is at the top.
Okay then, now that we have all that covered, I'm gonna tell you about the syntax of creating shaders and a small explanation. The syntax goes as follows: shader, and then the name of it and where it's placed. Okay, inside the square brackets we have the properties and subshaders. Inside the subshaders we have CG program defining some variables, we have some structs, some functions, and the end CG. And lastly we have the fallback. Okay, first off we have the shader name. This is where Unity refers to the material. Next we have the properties, which is where we'll have our interface. And after that, we will have our subshader. This is where all the shader code will be. Then we have the CG program. CG program tells the program to switch to the CG language instead of shader lab. Everything in CG language should be in here. As for defining variables, structs and functions, it's pretty clear what's going to be in those sections. So we are going to move on to implementation. We separated this part into 6 parts, where we created a colored bump map, lighting model, colored specular map, half diffuse shader, Toon shading and lighting, and Toon outlining. Now, firstly, we'll start up by starting up Unity. Then we create a shader in Unity by right-clicking and selecting shader in the menus. By doing this, we'll create the default diffuse shader which Unity comes with, as seen on the picture on the right.
Creating the colored bump map. First off, we start with the 3 properties: color, main text, and a normal map. In the color we always start with an underscore, so indicate that it's inside of Unity's interface. We give it the name color, and we give it some values. 111 is the starting color, which is white. We move it down to main texture, call it base RGB, give it a 2D, and the same with the normal map. Then we transfer our properties to our subshader using uniform, which makes it for more programs to access the same variables, and then give it a float 4 underscore color, and the same with the main texture and the normal texture. After declaring our variables, we then go to our surface function to build our normal information that we get from our normal map. To do this, Unity provides us with a function called unpackNormal, which takes the texture information and calculates the normal vector from it. The 2D texture we're going to look at is underscore normal map. The underscore normal map has a set of UV coordinates, which we get by en.uv underscore main text. We can take our calculated normal vector and write it to our surface output o.normal equals n, and then we can add our bump map into our underscore normal map area. Lighting model. In order to use a specular color map, we need to create our own lighting model. To do this, we create a function which takes 2 vectors a and b and returns calculated values between 1 and 0. The dot product tells us how two vectors are directed to each other, and to get values between 1 and 0 we use the normalized and the max to make sure that our values doesn't go below 0. All the lighting functions has to start with the keyword lighting and return a float 4. The function takes the surface output, calculates the surface function as a direction of the current light source, the direction we are looking from at the object, and the attenuation of the light source. Note that this function is called for every light source in range of the object. Inside the function we calculate the shading value with our created function. We then use to create the shader diffuse color by calculating with the surface, albedo, and the color of the light source. Finally, we return the color multiplied with and the alpha value of the surface, and now we can create the stellar diffuse lighting model. Colored specular map. To create this, we need two new properties: a texture for the specular map and the gloss value between 1 and 4. And this is done by defining it with the underscore as explained previously. And we need to create a new struct. In order to bring the color specular map over in the lighting model, we have to extend the surface output. So we need to create this struct and give it the necessary properties as seen. In this lighting function, we calculate the specular value just like the shading value, but this time with the sum of view direction and light direction instead of the light direction. We will use the value with the light color 0 and glass color to get our specular color. To see how it will affect our object, we will use specular color with our diffuse color in our return color variable. To get more control of the specular, we will create a pow function with our glossiness we created earlier. Now we have created a color bump map specular shader.
Now that we've gotten all that covered, we'll create a half diffuse shader. We'll do this by adding a new function called half diffuse term. We want it to return the values between 0 and 1. By doing this, we have to create two properties and two new variables. I called them shading and lighting. We implemented a step function inside our lighting function. The step function takes two parameters and returns 0 if the first parameter is greater than the other, and the other way around for the 1. What this does is that it will separate the light into 3 sections, give it a more cartoonish shading look. Okay, now that we have the shading and the lighting in place, we will do the Toon outline. To do this, we created two new properties and two new variables, and we called them outline and outline color. Okay, now we go inside our input struct. We insert float 3 view direction. The reason why we do this is that we want to give information about where our camera is looking at our object from. When we've done this, we go inside our surf function. Inside here, we'll add a float D, which will calculate the dot product of our view direction and the surface normal. Nextly, we want to reduce that value that we get to either 1 or 0 with a step function. With that value, we can decide which part of the surface has a regular albedo and which has our outline color.
So after the explanation, here's the code you can see.
Okay, here we can see our two materials with the shading applied. We can start to play with the gloss value or some shading and the lighting to get the desired look. And you can also play with the outline if you like that. But yeah, this is our product. Thank you for watching and have a good day.